So in example 5 here, we're going to be referring back to example 4. If you haven't just worked through example 4, what I want you to do is go back and just read over the scenario from example 4 because we need that to understand example 5. What this company was doing is they're interviewing applicants for a job, and they have 3 openings. So they want to keep interviewing until they get 3 people worthy of their openings. And so now they're telling us that it takes them 3 hours to interview an unqualified applicant, 5 hours to interview a qualified applicant. So remember, we're going to keep interviewing until we get 3 total qualified applicants. So let's think about how long that will take and try to set up a formula for that. I'm going to set up a variable. T is the time to find 3 qualified applicants. And let's think about how that would break down. So T, well, if you're going to find 3 qualified applicants, remember Y is the number of applicants overall. Number of applicants that we're going to talk to overall. Some of them are qualified and some of them are not. Y is the total number of applicants. And we're going to keep interviewing until we find 3 good ones. What that means is if we talk to Y people total and there are 3 good ones, then there are Y minus 3 bad ones. And each one of those bad people, each one of those unqualified bums, is going to take us 3 hours to talk to. So 3 times Y minus 3, that's how much time we spend talking to people who are unqualified. And then there's also 3 good people. And each one of those is going to cost us 5 hours to maybe check them out, run their background check, and really confirm that those are good people for our job. So let me simplify this expression. I get 3y minus 9 plus 15, which is 3y plus 6. So what I really want to do is calculate the mean and standard deviation of t of 3y plus 6. Let me calculate first the mean and standard deviation of y itself. And to do that, I'm going to detour through the variance because that, for me, is the easier one to calculate. So the mean, first I'll calculate the mean of y, the expected value of y. Remember, mean and expected value are the same thing. And the formula we have for that is r over p. That was one of our earlier formulas. I think it was on the 3rd slide of this lecture. That's for the negative binomial distribution. The variance, v of y, is rq over p squared. Now, we already have our values for r and p and q. Let me remind you what they are here. The p was the probability that any given applicant has the skills. So that's 10%. That's 1 over 10. Q is always 1 minus p. So that's 9/10. And R is the number of successes that we're looking for. So in this case, we have 3 job openings. I got that, by the way, from example 4, the fact that we have 3 job openings. So R is 3 in this case. So let me go ahead and calculate this mean and variance using those numbers. 3 divided by 1/10 is 3 times 10, so that's 30. R here is 3, Q is 9/10. P squared is 1/10 squared, so 1 over 100. So that's 100 times 27 over 10, doing the flippy-flippy over 100. So that's 10 times 27, that's 270. 270. But that's the variance and the mean of y, not of t. In order to find the mean and variance of t, we have to remember a couple rules of probability here. So let me remind you what those were. The expected value of ay plus b, expectation is linear. So it's a times e of y plus b. Variance is not linear. Variance of ay plus b. The interesting thing is that the b does not affect it at all. Essentially, variance measures how much a variable wobbles. And if you take a variable and just kind of move everything over, that doesn't change how much it wobbles. And so there's no b in the answer. It's a squared times v of y. So we're going to use those two values to help us calculate the mean and the variance of t. So e of t, remember t was 3y plus 6. Work that out up above there. E of 3y plus 6, which using my little formula over there is the a is 3. That's a, that's b. So it's 3 e of y plus 6. Now, the e of y was 30, so that's 3 times 30 plus 6, which simplifies down to 96. Our units here are hours. So we get 96 hours is the expected time that it will take this company to interview all these people and get 3 qualified applicants. The variance, which is not really what we're looking for. We're looking for the standard deviation, but it's very useful to find the variance because then you can just take the square root of that to find the standard deviation. The variance of 3y plus 6. Now I'm going to use my formula for a squared v of y. So that's 9 times v of y, which is 9 times 270. I'm going to leave that factored because the next thing I'm going to do is take its square root, and it'll be easier to do if it's factored. So let me find the standard deviation now. Standard deviation of that is always the square root of the variance, v of t. And so that's the square root of 9 times 270. This is why I left it factored, is I can pull out 3 square roots of 270. And you know what? I can pull out another 3 because there's still a factor of 9 under there. So 3 times the square root of now 30. 9 square roots of 30. 9 square roots of 30. That's not going to get any better until I pull out a calculator. And I did throw that into my calculator. I got 49.295 hours. That was, of course, an approximation. But that's my standard deviation in the time that the company should budget to conduct all these interviews. So that answers both of the questions that we were posed there. Let me show you where those all came from. First of all, the basic parameters of this problem came from example 4. So if you're a little mystified as to where these numbers up here came from, just go back and look at example 4. The premise of that problem was that 10% of the people we're interviewing are actually qualified. So we have a 10% chance of success every time we invite someone in to the office. And that means we have a 9/10 chance of failure. 9/10 of the people don't have the right skills for this particular job. And we have 3 job openings, so that's where the r equals 3 comes from. Now the tricky part here is to set up an expression for the time to find the 3 qualified people that we're looking for. Well, if y is the total number of people we interview, then that means 3 of them are qualified. So 3 of them are going to get that full 5-hour interview. That's where that 3 came from. And then all the rest of the people are unqualified. So that's y minus 3 people are left over, and they're going to get the shorter interview, the 3-hour interview, before we realize that they're unqualified. And so now if you just simplify the arithmetic there, it simplifies down to 3y plus 6. And we're going to have to find the expected value and the standard deviation of that. So I dredged up a couple of old and very useful rules on expectation and variance. Expected value of ay plus b is, since expectation is linear, it's just a times the expected value of y plus b. With variance, it's not linear, but what happens is the b disappears and you get an a squared coming out. So now the mean and the variance of y by themselves, we'll need those as a stepping stone to find the mean and variance of the time. These are formulas that I just got off I think it was the third slide in this video. So just check back. You'll see that r over p, that rq over p squared. And then I just drop in the values of p, q, and r to get the 30 and the 270 here. And then I have to find the mean and the variance of t. Remember, t is 3y plus 6, so that's where I use my old linearity formula. So I drop in 3 times the expected value of y plus 6. That 30 comes from here. And so that's how I get 96 hours. This company should plan to spend about 96 hours if they intend to get 3 good people to fill their 3 jobs. The variance there, this 3 squared is 9. That's using this formula right here. And the 6 just plays no role at all in there because it's like this b. So that just disappears. So we get 9 times 270. Standard deviation is always the square root of the variance. So I do the square root of that 9 times 270, and that reduced down to a decimal approximation of 49.295 hours. So that wraps up this lecture on negative binomial distribution. This is part of the probability series here on Educator.com. My name is Will Murray. Thanks very much for joining us. Bye-bye.